Bismillahirrahmanirrahim. Today we will discuss about exercise 3.4. Question number 2. Remaining parts of question number 2 of last time mathematics. We have already done some concepts, some theorems about proportions. So today we will again use them. Part 2 is find the value of m plus 5n over m minus 5n plus n plus 5p over n plus n minus 5p. We need to find its values and then we need to add them because it is requirement. And the given is m is equal to 10 np divided by n plus p. We will mention them as question number 1. Through this, first we need to make m plus 5n over m minus 5n. After storing this thing, we can see that for this portion, m plus 5n over m minus 5n, the componendo and dividendo theorem between m and 5n, because positive side on numerator and negative side for denominator is there. So we need to make the componendo and dividendo theorem possibility here between m and 5n. So m will be for numerator and 5n will be for denominator. So we can see here for numerator m is presented but 5n is not present on denominator. So we need to divide 5n on both sides. After dividing 5n on both sides, this, you can cancel this and by this and 5 ones are 5, 5 2s are 10. So we are left with m over 5n is equal to 2b divided by n plus b. Now we can easily apply here the componendo and dividendo theorem. So apply componendo and dividendo formula. It is your choice according to the requirement. Firstly, you can apply the positive and the negative. You can apply here the negative first and positive after that, but it is our requirement. M plus 5n over m minus 5n. So numerator plus denominator divided by numerator minus denominator is equal to same as for right hand side. I will do it, apply it directly. 2p plus m plus p divided by 2p and after that minus sign. We'll apply m and p. That will change all the signs of them. So now m plus 5p, sorry, m plus 5n that is equal to 2p plus p, that is 3p. So 3p plus n. And in denominator 2p minus p, that is p minus n. we are done with this value, which was our requirement n plus 5n over n minus 5n. So now our requirement is m plus 5p over n minus 5. We don't have any value of it, but we can find its value through given expression from equation A again. Equation 1 again. Equation 1 is m is equal to 10 into p divided by n plus p. Now you can see that comparator and dividend theorem already requirement between m and 5p. Mean to say m is on numerator and 5p is on denominator. But we can see that 5p is not here. So divide both sides by 5p. You can divide as it is on both sides. Cancel this p with this. 5 ones are 5, 5 2s are 10. Now you can apply here component dot dividend theorem. After applying it, we will be have m plus 5p over n minus 5p is equal to directly I will do this to m plus n plus p. And after that 2n minus, after minus sign you will need to apply the bracket sign, but I'm directly doing this because of some space problem. So minus I will change all these signs, minus and minus 2. So finally m plus 5p over n minus 5p is equal to 2n plus 7 into say it is 3n plus p divided by 2n minus n, that is n minus p. Now we have done with this value also. Now final requirement is addition of both of these. This will be question number B. I hope you can easily watch this. Okay. After that, our requirement is to add both of them. So I will erase all this. And after that, we need to do that and question number A and question number B. Why are we adding them? Because this is required. Okay. Add them. Left hand side. Addition with left hand side m plus 5 is equal to the right hand side addition with question B right hand side, that is you can easily solve this, but a little bit problem is its denominator is p minus n and its denominator is n minus 1. So you can change it with, you need to make them same. How you can make it same? I'm doing this here. M plus 5p over m minus 5p is equal to 3n plus p. I want to make this p sign positive and this n sign negative, just like this. Simply just to take common the negative sign from the denominator. So it will make change both signs of that. So I'm using here this terminology. This is just like same. So minus and plus sign coincides, and that will make change of sign. Now this left hand side you need to write it again and again. I'm just putting here, just because of time problem, you need to do all these things. So after that, just it will make change of the sign minus into plus, that is minus n minus p, it will make p minus n. Okay. So now p minus n, it is p minus n, 3n plus p divided by p minus n. This is also p minus n, and after changing this also is p minus n. So both of the denominators are same. This is for our convenience, and we can easily do the LCM. This is p minus n and this is p minus n. We have already knowledge that both are same. We need to write it once, and both numerators are as it is. But again, it's the same thing. After negative sign, you need to write it everything within brackets. So I will apply directly minus 3n, and this minus into plus will also be minus. We need to do all the steps, but I have some space problem. 3p minus p makes 2p, n minus cn makes minus 2n divided by p minus n. Finally, 2 can be common here. Take 2 common divided by p minus n and p. Cancel them, and your answer will be 2. And that's it. This was your second part of question number 2. Now we will solve the third part just like this. The third part of question number 2 of exercise 3.4, that is, find the value of x minus 6n. You can see that again complementary dividend theorem applied here, but for this time negative operation will be on numerator and positive, and this will not make any difference. This is also complementary dividend terminology. But here positive operation will be on numerator and negative will be on denominator. We need to find the value of this. If x is equal to 12, maybe over here. Now you need to find the value of this. Okay. So we need to find the value of x minus 6 or x plus 6 first. This one. So you can see that complementary dividend theorem applied here between x and 6a. Into say x will be a numerator and 6a will be on denominator. But we can see that x is on numerator but 6a is not on denominator. So within denominator, our requirement is 6a. So apply here to divide 6a on both sides. x over 6a is equal to 12ab power a minus 2 into 6a. Divide both of them. A cancellation with this a 6 1 plus 6 2 that. Now you are left with this. Now you need to apply componendo and dividendo theorem. But according to this requirement, negative operation will be on numerator and positive operation will be on denominator. So apply. Componendo and dividendo. So after applying this, just according to negative operation on numerator and positive on denominator, you need to make the same flexibility on the right hand side, just like for left hand side, same as for right hand side. Numerator minus denominator on the numerator side. So 2b minus operation will be first. So after minus, you need to make all the signs changed. So I am directly doing this minus a and then minus into minus plus b. And after that, positive operation will be on the denominator, that is 2b plus a minus b. So now 2b plus b makes 3b minus a divided by 2b minus b. That is a plus b. So this is equation number 8. This is the value that we have found. Now for second one, I will solve this again here. For this requirement, to find the value of x plus 6b over x minus 6b, but here positive operation will be on numerator and negative operation will be on denominator. So you can see that comparendo and dividendo theorem applied here between x and 6b. So our requirement is x will be a numerator and 6b will be a denominator. But here 6b is not on denominator. So you need to divide 6b on both sides. Now apply comparendo and dividendo formula according to this scenario. Positive operation will be first. This time because its requirement is this. Numerator we have not done this 6b dividation here. 6b, b will cancel to this b, 6 from the 6, 6 to the other. And you are left with 2a divided by a minus b. So this will be 2a plus a minus b, and in denominator 2a minus a, and this minus will change another minus sign plus b, or it becomes x plus 6b over x minus 6b is equal to 2a plus a minus b. 2a plus a, that is 3a minus b divided by b plus b. So this is question number B. Now we have two values, x minus 6a over x plus 6a minus x plus 6b or x minus 6b, both values we have. Now we can easily subtract them. For this time, we need to make subtraction between them. Subtract equation number A and equation number B. That is x minus 6a power x plus 6a minus x plus 6b power x minus 6b is equal to, we have removed the value of x minus 6 over x plus 6. That was divided by 6. 2b minus a plus b divided by 2b plus b minus b. So x minus 6a over x plus 6a value was 3b minus a divided by a plus a. Okay. The value was 3b minus a over a plus b. After that, negative sign, and then we have x plus 6b or x minus 6b. This value is 3a minus b over a plus b. Remember that for already presented negative sign here, almost both denominators will be balanced. So, for balanced situation, you don't need to do another step for making it balanced. Just take LCM of them, and both are same, so nothing to worry. Simply write numerator 3b minus a. After that, negative sign. This negative sign will change all the signs of them. Negative 3a and plus b. So 3b plus b, that will be 4b minus 4b divided by a plus b. So you can take common 4 b minus a divided by a plus b. And this time the answer will be just like this. And that's it. This was question number 4, question number 2, part 3. Basically, all parts are just like this. Part number 4, as it is, same operation with negative sign. We need to confirm also the answer of question number 2, part 3 of exercise 3.4. Okay, exercise 3.4, question number 2, part 3. Okay, this answer is same. Answer is same on page number 247. Okay. Part number 4 is same. Part number 5 is again same. You can easily do this. So first 5 parts are just like this. I have already done part number 1, part number 2, and part number 3. But for the last 4 parts, the terminology will be totally different, but very interesting questions. These are question number 2. Question number 2, part 6. Just to solve. Now you need to solve it. So just justify this method that already component and dividend theorem already applied here. Negative operation on numerator and positive operation on denominator. Because x minus 2 whole square, again x minus 2 whole square. X minus 4 whole square x minus 4 whole square. Just difference of negative and positive sign. You know very well about the componendo and dividendo theorem. That is, we need to find. So, how to solve it? Just to apply here after watching these things, just apply componendo and dividendo theorem. It is your choice. You can apply positive operation first and negative operation on the denominator. But the best choice is if negative operation is on numerator and positive operation is on denominator. So for easiness, you can easily apply this all is numerator, this all is denominator. So apply numerator. This is numerator. After that, I need to apply a negative operation first, and then denominator here x minus 2 whole square plus x minus 4 whole square. This is componendo and dividendo theorem, which I'm going to apply. After that, for denominator, I will apply a positive operation. So numerator, just like this. I can't change this sign because this is already the sign of Newton. This all is just like this. Now I will apply here rather than negative, positive operation and denominator will be here. Okay. Now apply negative sign, but also for the right hand side we need to apply here componendo and dividendo, but with same strategy. Negative operation on numerator and positive operation on denominator. Numerator minus denominator, numerator plus denominator. Just like this, numerator minus denominator, fraction, numerator plus denominator. Okay. So open these brackets, you will have x minus 2 whole square minus x minus 4 whole square. Negative operation will apply inside. That makes change both of signs. Negative x minus 4 whole square. Denominator will be x minus 2 whole square minus x minus 4 whole square. Positive sign will not make any change of the signs. Plus x minus 4 whole square. 12 minus 13, answer is minus 1. And 12 plus 13, answer is 25. Okay. So x minus 2 whole square cancel with this negative x minus 2 whole square positive, and this x minus 4 whole square and this positive x minus 4 whole square will change these signs. So you will have minus and minus, minus 2 x minus 4 whole square, and for denominator x minus 2 whole square plus x minus 2 whole square will make 2x minus 2 whole square is equal to 12 minus 13, answer is minus 1, and 12 plus 13, answer is 25. So minus 1 over 25 will be here. 2 will cancel to this 2, and then negative sign will cancel to this negative sign. Again, you can see that we have already x minus 2 whole square minus x minus 4 whole square, and in denominator x minus 2 whole square plus x minus 4 whole square. We have applied componendo and dividendo theorem here, and you will have this answer. Now you can see that this is x minus 4 whole square and this is x minus 2 whole square. We can write it as complete square as it is. And also 1 over 25, we can write it as, because we know that 25 is square of 5. We can write it as square. Some students also ask that, what if we apply here positive and apply here negative operation? We can judge that what will happen. If we are going to apply here positive operation and here negative operation, we need to say positive operation on the numerator and negative operation on the denominator. So, what will be that answer? X minus 2 whole square minus x minus 4 whole square plus x minus 2 whole square, because if this sign is positive, we can't make any sign change. So, plus x minus 2 whole square and plus x minus 4 whole square. So, you will left with this negative x minus 4 whole square and this positive x minus 4 whole square cancel. So, in the numerator, you will have 2 x minus 2 whole square positive and this will be positive on that case. So 2 into x minus 2 whole square on numerator. So here is the difference. For that scenario, you will have x minus 2 whole square on numerator. But if we are applying here negative operation, because for numerator that is positive and for denominator that will be negative. So x minus 2 whole square minus x minus 4 whole square, negative sign will change both of the signs. So x minus 2 whole square and this x minus 2 whole square sign will be different. So both can cancel. So this can be x minus 4 whole square and this can be also negative x minus 4 whole square. So minus 2x minus 4 whole square will be on denominator on that case. But this will make the step. These steps are so easy according to that. So now we need to solve it. For solution, we need to find the value of x. So conclude that abolish this square by apply square root on both sides. Okay. Square root on this and square root on this. Cancel square root in this case. And you will have finally x minus 4 over x minus 2 is equal to square, and after applying square root you will have two roots, positive and negative, plus 1 over 5 and negative 1 over 5. So now x minus 4 over x minus 2 is equal to 1 over 5. That is first. You can separate them and then x minus 4 or x minus 2 is equal to negative 1. Now find both the roots by cross multiplication. Here and here. Cross multiply them. 5 multiplied by x minus 4. So it makes 5x minus 20 is equal to x minus 2. Find the values of x. X will be here, minus 20 will be here. So 5x minus x will equal to minus 2 plus 20. 5x minus x will be 4x equal to 18. So 4 will be divided there. 2 2s are 4 to 9 are 18. So now first solution is 9 over 2. This is our first solution, and last solution for here 5x minus 20 again. After cross multiplying them, negative x and plus 2 will be here. Find the value of x. 2 plus 22. 6x is equal to 22. 2 plus 20. So now 2 3s are 6, 2 11s are. The second solution is value of x is equal to 11 over 3. This was part number 6. In the next lecture, we will discuss the remaining parts of this exercise. These are all questions, just do more and more practice of this exercise. Now, if you have any question regarding today's lecture or any previous lecture, you can ask it now. Thank you.